Hey, this is Mr. Coker with Algebra Lesson 4.1 Introduction to Exponential Equations. To start with, this is the basic exponential equation. Y equals AB to the power of x. In this equation, A is your y-intercept and B is the amount that the amount that you're multiplying by each time. You could also see it written as y equals AR to the power of x. Both are common. So in order to do this, to show this, how it works, I've got three examples. The first one, and you'll notice each time it's y equals y times 2. The reason for that I picked those numbers is really just to keep I don't have a lot of space on my graphs, so I want to keep the numbers fairly small. So I've got y equals 1 times 2 to the power of x. Now, 1 is your A value, your y-intercept, and 2 is the amount you're multiplying by. What this means is every unit that we go this way, every x value, our y value will double. And I want to show you this. So this is our graph. What I'm going to do is make a t-chart. We're going to do x and y. The first number that I'm going to put down is going to be, I'm going to put a -1. Now if I put a -1 in place of x, think about what that will do. What that's going to do is make the exponent -1. Now if you remember the rules of exponents, that will cause 2 to the power of -1 is the same as 1/2. 1 times 1/2 is 1/2. I suggest use a calculator, certainly when you have negative exponents. Next, I'm going to put 0. Again, the exponent rules, anytime we put a 0 in place of it as an exponent, if anytime you have an exponent of 0, it equals 1. And I often describe this as 2 to the power of 0 equals 1, 5 to the power of 0 equals 1. This Nintendo 64 controller to the power of 0 equals 1. Just as an example. So this makes 1 times 1 is 1. And I want to point something out. Remember, this value is the y-intercept. Well, when x is 0, y is 1. So if we graphed it, it would look like this. We'd have a point, the y-intercept is 1 as it's supposed to be. Now I'm just going to make a couple more points right now. When x is 1, 1 times 2 to the power of 1 is 2. 1 times 2 to the power of 2 is 4. Put those in a calculator if you need to. So I just want to show what this graph will look like. So when x is -1, y is 1/2. And this right now is what we have. This is an exponential graph. I want to point out something though about this graph. I'm actually going to go a little bit further. So this graph, look at it. You notice it's going up, it's curved, and it's going up. That's what an exponential graph should look like. I want to point out something very important. That is right here. What do you think? Do you think it goes down and will keep going? because it will not. And I'm going to show you why. Now, I'm going to keep this here, but I'm going underneath it, I'm going to draw a few more x's and y's. I'm going to go back past -1, I'm going to put -2. Now, if we put in a calculator 1 times 2 to the power of -2, we get 1/4. -3 would give us 1/8. -4 would give us 1/16. What I hope you notice is it's being cut in half every time. And if we graphed it, this is what it would look like. It's cutting in the numbers, the fractions, the y values, they're being cut in half every time. Being divided by 2, essentially. And that's because of the rules of exponents. If you don't believe that, you can put it in a calculator and you will. So this thing I want to point out, this line is called the asymptote. And that's the lowest point on a graph that nothing can go, that your graph will never go under. It will never reach, actually. And that's 0. So our asymptote is 0 in this one. And the reason for that is, if we keep going forever, it will get infinitely closer to 0, but it will never quite reach 0. So this thing I want to point out. Do you see a number off to the side of our equation? The answer is no. There's no constant. Since there's no constant, well, we assume the constant is 0, right? We don't have to put plus 0, but it's assumed. Your constant is always your asymptote. Hopefully you can look at this one and figure out what it's going to be. Okay, spent some time on this first one because I want to make sure that everyone is clear. This is your y-intercept. Your y-intercept, that's how much you're multiplying by. It's your base of your exponent. It's how much you're multiplying by each time. This is the number which is always your constant. That's called your asymptote. And we can graph, if we need to, with an XY chart. With practice, you won't really need to do that. Hopefully you'll be able to, especially when you have numbers like this, whole numbers, it will be easy. When you are working with like word problems, that's probably not the case. You'll probably need the XY charts. But okay, look at the second one. The second one is a transformation. And the transformation is here. It's in the exponent. That is a left-right translation. And what this is going to do is going to make it so that I'm going to pick many of the same numbers. I'm going to start with -1, 0, 1, and 2. If I put 1 times 2 to the power of -1 plus 1, well, what's -1 plus 1? It's 0, correct? So that's 1. That means that 1 times 1 is 1, so we would have a point here. I put in again, 1 times 2 to the power of 0 plus 1. Well, that's the same as 1 times 2 to the power of 1, which we have here. 2. And as we go on, 1 times 2 to the power of 1 plus 1 is 4, and then 8, and so on. And if we go backward, we're still going to go the opposite way. So I'm going to go ahead and plot these points. Well, hopefully neater than, I'll draw my graph neater than that. I want to point out, and this will, just like we had before, our asymptote is still going to be 0. And that's because we don't have a constant. That 1 is in the exponent. It's not constant. It's part of the exponent. This is the point. What happens when you add a number to the exponent? You shift the graph. These graphs, and this is the reason I want to keep picking the same numbers. These graphs are the same. The difference is this one was shifted to the left. It's +1, but one way to think of it is just like when we did quadratics, and if it's in parentheses, we shifted it to the left. We did the opposite, I should say. So +1, if it's in parentheses, went to -1, and -1 went to +1. Same thing with exponents. I'm not going to do this part. Hopefully that's self-explanatory, and you can see it as you do the problem. Anyway, a translation in the exponent shifts left and right. So let's see a translation up and down. Hopefully you remember I just said about the asymptote. Here we have we had an asymptote also here of 0. Our asymptotes so far have been 0. When we are doing a problem like this one where we add a number at the end, we add a constant. Well, let's do XY chart again. Hopefully you don't need it, but in case we do, -1, 1, -1, 0, 1, and 2. Well, now we're going to get the same numbers we got over here, but we're adding 1 to it. So it's 1 times 2 to the power of x plus 1. So -1 before gave us 1/2. If we add 1 to that, we get 1.5. Which is, I'll write as 3/2. Just a simplified fraction. But it means 1.5, so go ahead and plot that. -1 on the x, 1.5 on the y. 0 before gave us 1. Now 0 will give us 2. We're adding 1 to it. Same thing here. Before we had 2, now we're going to add 1 to it. Get 3, followed by 5. What this is going to do, let's see, 0 and 2 go up by 1/2. I'll make a 5th mark up here. This is what it's going to do to our graph. What it's doing is it's taking our basic graph, our non-translated graph, and it's just adding 1. It's just shifting us like we took this graph, picked it up, and placed it 1 notch higher. And we do have an asymptote, of course. The asymptote is 1 on this one. Our asymptote is 1. So, it's a lot of information. It's just an introduction. Later on we'll get to other things with exponentials, finding certain, we'll get to different things later. One of the big things that we'll get to, probably next major thing, will be finding rate of change. And then later on in behavior. So, here we go, and this is it. So, one last time, this is your basic equation. The A and B are going to be given to you typically as numbers. And we have y equals 1 times 2 to the power of x. That's your basic equation, like parent function. And this equation, we have an asymptote of 0. We have a y-intercept of 1, and we have we're multiplying by 2 every time. Growth vectors. Fancy word for it, of 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. on this equation, it's the same equation, but we added 1 to the exponent, which shifts it to the left. And then on the last equation, we have the same equation as the first one, but we shifted it up 1. We added 1 to the constant of 1, so we shifted up 1, and now we have an asymptote of 1. So, thanks for watching, and have a nice day.